Hey, welcome back. Dr. Mitt here, just making a short instructional video to help you as you review what we've studied so far about the atmosphere. So we're thinking about the atmosphere in terms of its structure, the structure of the atmosphere. We can think of the structure of the atmosphere both in terms of gas composition and in terms of temperature. So we're going to have a diagram with two parts. We'll go ahead and draw the Earth's surface down here. We'll add a couple of sort of nondescript plants. Maybe we'll go ahead and add a sixth grade student just to show us this is the Earth's surface. If we think of the atmosphere in terms of gas composition, we're going to have a dividing line here between the homosphere and what's called the heterosphere. The homosphere and the heterosphere. Remember that the division between these is at about 80 kilometers above the surface. The homosphere is characterized by a sameness. A sameness. The root here, homo, has to do with sameness, and so we have the idea of sameness. We can also say that it's well mixed. The gases of the atmosphere in the homosphere, from the ground level all the way up to 80 kilometers, is well mixed. And the composition of that well mixed gas, that we call air, composition of air, is, of course, 78% nitrogen, 21% oxygen, and 1% other gases. Argon actually makes up a big chunk of that 1%. But of course, water vapor, moisture, carbon dioxide, things like that, methane make up this 1%, part of this 1% also. So the homosphere is characterized by sameness. It's well mixed. The air that we breathe is of this composition: 78% nitrogen, 21% oxygen, 1% other gases. The heterosphere, on the other hand, is characterized by differentness. Again, hetero has to do with differentness. And this part of the atmosphere is layered. So as we go up from this dividing line, the first layer here is oxygen rich. Above that, it is helium rich. And even above that is hydrogen rich. Of course, even higher than this, we'd be going out into space. We'd no longer be in Earth's atmosphere. So in terms of gas composition, we have the homosphere and the heterosphere here. Everything's well mixed, air of this composition. And in the heterosphere, we have a layering of gases. Again, this is on the basis of their own mass, right? This is a heavier gas than this. This is a heavier gas than this. Just think of their atomic numbers, and we understand that. On the other side of the diagram, we're thinking in terms of temperature. And so our layer closest to the surface, the layer in which we live, is the troposphere. And our other way of thinking about this is that it is the weather layer. This is where all weather happens. Pilots like to get above the weather. They like to avoid weather for the sake of their passengers and the safety of their aircraft. And so they often tend to try to get up higher than the weather layer for their cruising. The troposphere ends at the tropopause. Each one of these layers ends at something pause. So we have the troposphere. Above the troposphere, we have what is known as the stratosphere. Stratosphere is significant to us because this is where we can encounter, and I'll do my imperfect airplane, this is where we have the jet streams. The jet streams are at this elevation or altitude, I should say, above Earth's surface, of course, it changes its position north-south, and that can actually be what causes us to have winter weather when we have winter weather, cooler weather when the jet stream dips farther south. That can affect what's going on outside in our atmosphere. Another thing that's significant about the stratosphere is it's the location, something we'll study in more detail later. This is the location of the ozone layer. So the ozone layer is within the stratosphere. Stratosphere, of course, ends at the stratopause and is followed upward by the mesosphere. The mesosphere. What we remember about this is that it is the coldest part of Earth's atmosphere. Please note that the top of the homosphere, the top of the mesosphere coincide. They're in the same location. So the mesopause is where the mesosphere ends. And above this, we have the thermosphere. You look at a thermometer to see how hot it is. And so this is actually the hottest part of the atmosphere. There is an end to the thermosphere. There's something above that that we refer to as the exosphere. This is the last little bits of gas that we have, the last bits of atmosphere before we're out into the depths of space. So we have this diagram that helps us to think of the structure of the atmosphere in terms of gas composition and also in terms of temperature. We have the homosphere and heterosphere here. On the other side, we have the troposphere, stratosphere, mesosphere, and thermosphere, above which we encounter the exosphere. Not much atmosphere left there. After this, we're out into space. So hopefully you find this short video helpful. Refer to this as often as you need to. You can stop it where you need to if you're working on practicing the diagram. And of course, this is something you'll encounter on a future assessment. Thanks for listening so much. Bye-bye.